Welcome back to Command Line TV. This is episode 11, and today we're going to talk about file systems. But first, do we have any follow-up from last time?
We did have a follow-up question regarding shell scripts, or just scripts in general. After writing a script, can they be saved anywhere, or is there some sort of general practice as to where to store these files?
Yes to both. They can be saved anywhere, and there is also sort of a practice. What determines it is whether the script you're writing pertains to a particular set of files in one directory. So if it's something that is always run from the same place, then I like to just keep it in that place. And then you can run the script using // like we did in the example last time. However, if it's a script that you might want to run on files in a bunch of different directories, the simplest thing to do is to make that script is to put it into a directory that's on your path. So the path is something that is used to determine where to find executable files, right? So I'm going to do echo $path. Path has to be all caps like that. And this is a bunch of directories separated by the colon character, where the shell will look for programs that when you type them. So when I type like ls, it's finding the ls executable in one of these directories, and we can tell that it's actually in user bin, which is the first one. So what we could do is write our custom scripts and then move them into one of these directories so that the shell will automatically find it when we want to run it. But all of these directories are protected. They're only accessible for writing by the super user, by the administrator. So you could, if you have administrative privileges, copy your script into there. But what's more typical practice is to create a corresponding directory within your own account for your own personal scripts. So for example, you might want to name it after these, which are all called bin. Bin is just traditionally, it stands for binaries, which is like executable files. But traditionally, that's the name of a directory where that goes into your path. So I'm going to make my own bin, but put it underneath my home directory, like that. And then I could put my scripts into there. So I wrote these scripts last time, like hello.sh, right? So if I move hello.sh into ~bin, then I'll be able to find it there, but that's not on my path yet, right? My path doesn't contain ~bin. So what I would have to do is, in my bash RC, set up like that my path should contain, and in some cases, writing tilde doesn't expand properly to your home directory, so you can use $home instead. I just, out of habit, I think that's a safer way to do this. So what this does is I'm just taking the existing path and adding my ~bin onto the front of it. So when I save that, and then if you log in again or just reload that bash RC, now you see home CLTV bin on the front of my path, and that means that the hello.sh can be found there no matter where I am, right? So I'm in downloads now, but if I just type hello.sh on the command line, then it's going to run that script. And remember, we left an error in that script, so let's maybe go fix that. So this should say echo save. Whoops. Oh, permission denied. Interesting. What did I do there? Okay, so this is from when I was playing with the permissions. Yeah. So I wanted to illustrate some of those octal codes for permissions, and I made it so it's not writable by me, which is kind of annoying. So let's review that. I can do user plus W to say that I should be able to write that. ~bin hello.sh. Okay, that's better. So now I can retry the nano. Echo, save, exit, and now hello.sh will give me those messages and then run the command that I told it to run. And I can run that from anywhere because it's on my path, right? So if I go into pix, then I can do hello.sh and see what's in the pix folder.
So the term file system can refer to many different things. I guess where we should start off would be is what exactly does file system mean to us as a user?
Sure. Just like a lot of other terms on Unix systems, file system gets overloaded to mean multiple things. The simplest thing that it's used for, though, is just the files that are accessible to you on your system. So if you start at the top of your file system, which we call the root directory, that's another term that's overloaded a lot, is root. So the root directory is just called /. It's the very top of our file system. And within there are a bunch of directories that go deeper into other subdirectories and so forth. And we can use file system to refer to this entire tree structure. So you could say, like, are there any files on your file system that have the extension, .bak or something like that? And there are commands that you could use to figure that stuff out. But that's referring to file system as the set of files that are available. There are other ways to use file system as a term, and one way is that it refers specifically to the format of the way the files and directories are actually represented on the device. So how are they represented as bits? How do we represent things like the file name and permissions and other attributes, the modification time? Different file system formats could have different capabilities. So there might be a format that supports very long file names and another format that has a limitation on the file names. There could be file formats that support a journal, which means that when your system goes down or loses power or something, you can recover what was going on from the journal, and it helps prevent corruption and things like that. So lots of different features that can be built into the way that files and directories are represented as bits on the device. There are also virtual file systems, which we'll take a look at. One kind of virtual file system is that it can give you access to some kind of database or data structure that's part of the operating system, but it shows it to you by exposing it as if it were directories and files. So you can use the regular tools like cd and cat and head and grep to search through and browse these data structures. Another type of virtual file system is when you've got like a disk image, and this is something that's a little familiar to other computer users too. Like you can download an image file that represents a file system as it might appear on a CD or something like that. And then you can actually take that and mount it as if it were a CD. And so if you've used things like VirtualBox or other virtual machines, you've probably interacted with those disk images.
So in regards to file systems, like we just mentioned, working from root in the terminal, we've done things in this directory before. We've accessed the etc folder to change our bash RC configurations. We've also accessed the user directory. What are the other files and directories within root?
Yeah, these are some cryptic looking directories up here, some of them. And they're all kind of somewhat loosely standardized by a thing called the File System Hierarchy Standard, or FHS. This is a document that different Linux distributions use to kind of manage where things should go on a system. And a lot of it is just common practice that gets standardized over decades, really. But I can describe some of these high-level directories. So yeah, we've looked at etc. This is a lot of configuration files. So one thing that we got out of there was the password file. So the users that are on your system are defined. Oh, that's interesting. What did I do wrong there? I'm in my home directory, so there's no etc subdirectory from home. I had to put the full absolute path like that. and then I can see the password file. So there's lots of other stuff like that in etc that has to do with different configurations of the software in the system. The home folder is where your user accounts go. So we have home/CLTV or home/username in general. Boot is where we've got the kernel images. So when your OS first boots, it's going to look into that directory and find these image files. That's what it loads into memory and starts executing in order to boot the system. Let's see, root is just the home directory of the administrative user. So just like regular users have, like home CLTV, root has a /root, which we're not allowed to access unless we are root. But that's another way that root is confusing, because I just told you that this is the root directory, but then there's also /root, which is, I don't know, root or something. Okay, user is a big one. So a lot of the installed software goes into these different trees, these different hierarchies. Within each tree, you've got a standardized set of directories like bin, lib, share, and a couple of others depending on the situation. So I've got a few of those here at the very top level. So root itself is one of those hierarchies. I've got bin and lib here. And the programs that are in /bin are considered to be like the really, really essential programs that you need to like boot up the system, to get things running, to explore the system if maybe something goes wrong. So they're, generally speaking, like the most important applications that are available. And then user bin, now I'm seeing something interesting here on this system, which is, so this is going to contradict what I just said. On this particular system with Arch Linux, they've decided that /bin should just be an alias. This is a symbolic link, which is a file system alias, to user bin. So in other words, those are the same directory on this system. Some systems, bin will be just the essential stuff, and then user bin can get mounted later, and it contains many, many more programs. But here they're the same. So I'm not going to get into that distinction anymore. So within user, you've got the bin and a separate etc, lib, share, and so forth. And the idea with this sub-hierarchy is that your executable stuff goes in bin, and that's what people put in their path. So traditionally those were compiled machine code, but they also could be scripts of various kinds. Lib is for libraries that get linked into other programs. So when you're doing programming, you might link to some library and include those, import that stuff. And then I can show you some examples in there. So star.so, so is one of the extensions for libraries. So for example, if you have a program that uses the magic ++, this is the image magic library, and then maybe you use JPEG utils, or libz is for compression or stuff like that. So your executables can refer to libraries in that lib folder, but they're not themselves directly executable. And then share is for stuff that is not binary. So it's like data files, could be documentation files, licenses, things like that. So there's usually a user shared doc, which contains, like, for just about anything that's installed, it contains the documentation. So I think we looked previously at ImageMagick documentation in there. So that's kind of gets to the hierarchy underneath user, but then that same structure gets repeated in lots of other places. Like a lot of systems will have user local, and then the idea of user local is that this is stuff that you personally, as the administrator of this machine, would install. So I might have a few things there, not very much usually, but these are things that I have installed without using the package manager. So the package manager takes care of the user hierarchy, like user bin. But if I want to install something manually, it can go in user local bin, and then it won't conflict with the packages that the package manager installs. So the couple of remaining directories at this top root level that I want to focus on are var. Var is where things like log files and temporary files, caches go. We can look into the first level of that. So it could be, there's cache and log and email you send and stuff like that. So occasionally you might have to go in there if you're debugging a serious system problem to take a look at log files, but it's going to depend on exactly what you're trying to do, so there's not much use in exploring that at great detail right now. Let's look at proc though. This is a pretty interesting one. Proc is one of those virtual file systems, so it's giving us access to data structures inside the operating system. And these numbers here are directories which correspond to information about each process that's running on the system. So it's got the process ID, and then within there you can see some information about that process. But there are some other things here. One that I'd like to look at is file systems. So if I cat the file systems virtual file, the operating system is going to report to me what file system formats it understands. And a lot of these that start with no dev are the virtual ones, including proc itself is in that list. Just up here, there's proc. But then the ones without no dev are the actual physical formats for disks that it can use. So VFAT is a somewhat older format used by Windows systems, and it's still used today on lots of like the USB drives and so forth. And then the native system for most Linux devices is called EXT, and the current one is EXT4, but there are some older versions of that available. So this tells us what formats the operating system can understand. Another interesting file in here that I've had to set on multiple occasions is, let's go down to procsys fs inotify. Okay, so inotify is a service that allows a program to get notifications from the operating system when files change. So for example, if you've got a backup program, right? So a program that's running in the background that might be making backups of all of your files and shipping them off to a server somewhere, encrypting them and so forth. That backup program will want to know when files change, because then it should make a new backup of that file. So there is a limitation to how many files one of those programs can be watching. So that's in max user watches. This appears to be a file that just contains this one number, okay? But actually, that is a setting within the operating system, and I'm just reading that setting by using cat. But if I want to change that setting, I can also redirect to it. So I could do something like echo, let's say 1048 700. So I'll add a couple of extra watches, and then I would redirect into that file. So that's how I could set a new setting for that variable. Now the problem with that is that you need to be the administrator to write to that file. So if we take a look at its permissions, it's owned by root and writable by root, but not writable by anyone else. So that explains that. You would think that you can just do sudo to fix that, but you can't. The reason that that doesn't work is a little bit subtle, but when you do sudo, it's running the echo as the administrator, but redirections don't become part of the sudo. The redirection piece is still done by your local user, the current user. So that's not enough. What we actually would have to do is get a shell owned by the super user. So sudo supports -s, and I've got to type a password here. And now I can tell by this # that I am the administrator. So I'm going to do this same echo with the redirection. And now, if I cat that file, it took on the new value. So I'm actually using file system tools like cd and cat and redirection to tweak parameters within the operating system itself. And now my backup program will be able to watch even more files at the same time.
So now that we've looked at some of the file system hierarchy in terms of the different directories it contains, what if we want to do something with a USB file or a thumb drive?
Sure.
How can we do things with this? How do we, add it to the system, locate it, format it if necessary?
Mm-hmm. Good example. So I'm going to take this and plug it right into my laptop. And what will happen on many Linux systems that are like pre-configured to be friendly, so Ubuntu and those sort, that have a desktop environment on them, a lot of times that will just pop up a folder, just like on Windows, that it's already been mounted automatically and you can start using it right away. But we want to learn about what happens underneath that. So I don't have my system configured to do any of that. What we've got to figure out is what is the device name on the system that corresponds to this drive that we just plugged in. So there's another directory from that top-level hierarchy that I didn't introduce yet called dev. And inside dev, you've got a bunch of stuff that represents different sorts of devices on the system. So they could be some kind of input-output device, storage device, sound cards, all sorts of things in there. But the ones that we're mostly interested in are the ones that start with SD. On some systems it could be HD, but these are like hard drives of various kinds. So if I look for SD star, and this yellow, I'm sorry, is a little hard to see. I could tell LS to not to color that. So I've got SDA is my main disk, and then SDA1, SDA2, these are partitions of that disk. Okay, so I'm not going to play with SDA because that's my real actual disk, and I don't want to mess anything up. But now we've got SDB, and this only showed up when I plugged in that drive. There wasn't an SDB here before, and SDB1 is a partition on that. So generally speaking, you can just use SDB directly, but a lot of times what you'll do is create like a single partition that takes up the entire drive, and that would be called SDB1. So in a way, it's not really a partition because it's still the whole drive, right? Partition you think of as breaking it into pieces. But you're using the partition table on that drive to still have one partition. Okay, I just want to prove that when I unplug this device now, and I do that ls again, the SDBs have disappeared, right? So the dev file system is one of those virtual file systems that automatically updates based on which devices are accessible or not. So that device is SDB. Another thing that I can do to kind of investigate the size of the disk or the partition structure is a simple command called fdisk, and -l will give me detailed listing of partitions just like ls-l. And then I give dev SDB. But to open a disk in this way, to be able to look at the partition information, you need to be the administrator. So I'll do that. And now we see that this drive is about 960 megabytes. And here is the one partition that starts and ends at particular places. And this partition is formatted as FAT16, so one of the old Windows or even DOS partitions. That makes it readable on lots and lots of different machines, which is good. But it doesn't have a lot of the features that we might expect of a modern Linux file system. So first I'm going to mount that file system so that I can see the files that are there. to do that, we do a command called mount. And first you give the device name, so that's sdb1. And then you give a directory on the system where those files will appear. And basically, it could be any directory. Usually it's empty. But there is a built-in directory I've got here called mnt, or mount, which is specifically for these types of temporary mounts. So I'll put it there. So now if I look into /mount, I've got files here that correspond to, or that are the files on that drive. And then unmount is actually spelled umount. For some reason they thought that saving that one character would be helpful. So I can, when I unmount, I can either give the device name or the directory name. Either one works. And now, if I look back in that directory, it's empty again. There's nothing there. So it's unmounted, and now it's safe to remove the device. So let's say I want to reformat that. I'm not going to repartition at this stage, but I just want to reformat using a Linux file system. There's a command called makefs. This is the format command. And there are a lot of variants of it, so I'm hitting tab here to see the different variations. You can just do makefs and it'll use some default format. I think it will be ext2. But if I want one of these other ones, I can specify that. So makefs.ext4, for example. And then there are different options you can specify here about how to lay out the system or how much space you want to reserve for different things. But generally, you don't have to say anything else. You just give the device name, so sdb1. And reformatting a disk is dangerous. You're going to lose all the files that are on it currently. So you want to make especially sure that I didn't type A here, because that's my real disk. So sdb1 makefs. Oh, permission denied, of course. So sudo that. And it's got a little protection here that it already seems to contain a file system. So are you sure you want to reformat? Yeah, let's go ahead. So it goes through and creates the format on that disk. And now, if I try to mount it again, let's say mount dev sdb1 into mount. That worked. And now the files that were there before are gone. There's this directory called lost and found. This is a feature of ext file systems where basically if there are fragments of, like if the file system gets corrupted, which is pretty rare these days, but if it gets corrupted and there's some fragments of files that it doesn't know where they belong, it puts them in the lost and found folder, and maybe you can make sense of them at a later time, but it's not usually useful. It's just always there. So I've got this new file system mounted, and I can go there. I can create directories. I can create a file. This is on my new drive. Okay, so write that, exit. Oh, I'm still in tilde. I didn't mean that. Okay, /mount. Oh, yeah. So, so I did all of that in tilde. That wasn't the right thing. So I'm going to just move readme, let's say, into /mount. Permission denied. Interesting. So the way it mounted this, because I mounted it as root and I didn't give permission to other users to access it, then my regular user can't do that. What I could do there is do a chmod and say that everyone is allowed to rewrite and execute that folder. Okay, and if I do that, did we do ls-a before? This is what shows the dot files, the hidden files, yeah. And one of those is dot, so this is a representation of that mounted directory itself. And it did not add write permission for group and others, so I'm going to be more explicit about that. Let's see if that works. Okay, so now everybody is allowed to write to that mounted disk, which means that I should be able to repeat this command to move readme over to /mount. and now that exists, and it's owned by this user, and so forth. So one thing that having this ext file system on the USB drive means is that I can have file ownerships that make sense to this system. I can do things like symbolic links and other file system features that Linux file systems support, but FAT systems do not. Okay, so I've got the README file there. Let's unmount that. So now it's empty, and then when I remount, I just lost it. That appears exactly as it did before, with the same permissions here, and with the owner, kept track of there. So one thing it does mean, having that drive formatted with ext4, is that now this will be pretty useless on Windows or Mac systems. The ext system really only works on Linux. So if you want a drive that can be transferred between different operating systems, you need to format it with a file system that works on all of them. Thanks for joining us today. Next time I think we'll cover more about searching through file systems using commands like find and locate, and then xargs, which also gets used quite a lot with find. So see you then.